Alright, party people, so we are going to do passage 2.2, questions 8 through 14 today. So, I am struggling to turn the page. So, passage 2. That's what it looks like. We're going to go to the questions first, as always. Never waste your time on the questions because you may not have to read them, or at least all the way. Or never waste your time on the passage. So, based on table 3, that is my locator, it can be concluded that the magnetic field generated by the wires in experiment 3. So, before I even read this, I'm going to go to table 3 and experiment 3. So, experiment 3, coiled wire, table 3. So, let's see what happened here. A coiled wire was mounted on a pole and a metal ring was placed. The current was set through the wire, producing a magnetic field that caused the metal ring to float up the pole. The students used the same amount of current and kept the diameter of the coils fixed, but used wires with differing numbers of coils. So let's see, let's just look at this. As we increased the coils, the height that it reached increased. So as we had an increase and an increase on this one. So these align. So let's see. So the wires, the magnetic field generated increased as the number of coils increased. Cool. That has increase and increase, which is what we saw in our table. So that is evidence from table. All you had to do was find your trend. That's a trend question. So that is an IOD question. All right, number 9. In experiment 2, that's my locator. If a coil were slowed down to 0 meters per second, what would the EMF would correspond to the EMF recorded? So 0 meters per second. Rotational velocity was 0 meters per second. So again, I'm looking at table or experiment 2. So this says, in experiment 2, a coiled wire was rotated at various speeds corresponding to these. So, special connectors called slip rings allowed the coil to rotate without tangling. That doesn't matter. We measured the maximum EMF. The setup was here. So our rotational velocity was down to 0 meters per second. Okay, well this actually doesn't say anything about rotational velocity, which is what is going to make this difficult. So I'm going to go back to our answer choices and let's see. We have trial 5, trial 6, trial 7, and none of the trials. So this asks for rotational velocity of 0 meters per second. And 0 actually, well 1, the number 0 isn't anywhere on that table. We don't see it. And we also don't see this word. So there's nothing to match in there. So I'm actually going to say none of the trials, right? So experiment 2 doesn't talk about rotational velocity. It talks about changing the field. Let's see what they actually changed. So it says that constant magnetic field at various speeds. So they did change the speed, right? But none of these are 0. Okay? None of them. So we're not going to go with that one. Let me know if you have questions on that in class and I can stop. Okay, based on experiment 1, that's my next locator for number 10. Which of the following would provide the highest maximum EMF reading? So I'm looking for the largest because maximum means the largest. So I'm going to go back to experiment 1. It was passed at varying speeds with a diameter of 2 centimeters. The various speeds corresponded with a change in the magnetic flux. We used a voltmeter. So we want the maximum EMF. So let's find the largest EMF on this table. So maximum EMF, that is 0.85. So that's a change in 0.9. Trial number 4. So now we're going to go on. So we had a change in flux of 0.9 produced an EMF of a change in flux of 0.9, 0.83. So what does this mean? Moving, so that's going to be our speed. So this was the highest speed on the table. Highest speed on the table. So, let's see what we did. Moving the magnet quickly and using a magnet with a strong magnetic field, maybe. Magnetic with a weak magnetic field. Moving the magnet slowly with a strong magnetic field. Moving the magnet slowly using a magnetic with a weak magnetic field. So let's see what we actually did here. So, again, we have the highest speed on the table, and this is the largest magnetic field. So, because it says the speeds corresponded with the changes. So, if this is high, so if the magnetic field is high, that also means the speed is high. So, we want both of those things to be high, which makes my answer choice F. Alrighty, number 11. Just decapitated a pen. Decapitated, because the cat fell off. I'm hilarious. I'm sorry, that was awful. I apologize for that 1,000 times over. And this is about to go on YouTube, so it's there forever. I'm so sorry. Alright, anyway, number 11. Based on the results of experiment 1, which means I'm going to be looking at table 1. What's the relationship in change in magnetic flux and maximum induced EMF? So, we're going to turn this table into a graph. Nope, we are going to turn this table into a graph. So, as this goes from 0.3 to 0.9, that's an increase. This goes from 0.22 to 0.85, that's also an increase. So we want a graph that shows me when one is increasing, the other is also increasing. So, I'm going to say this one, because it is a positive relationship. When one is increasing, the other is increasing. 11 was shortly into the point. Now I'm going to undecapitate this pen by putting the cap on. Pick a new color for number 12, and we got 3 more questions. So, in which of the following trials from experiment 1 was the magnet moved at the slowest speed? Okay, well, this pen sucks. So, the slowest speed. Alright, so we're going back to experiment 1. That's our locator once again. Now remember, this part is important. The various speeds correspond to the magnetic flux within the coil. So that means if this part of the table is high, then the speed is high. So which one has the lowest? Because we want the slowest. So slowest equals lowest. It literally has that word in it. Boom. So that is this one, and that is trial 1. These are mostly IOD questions, just which lets you know that you can have data questions when you're talking about an experiment. This is a type of passage, not a type of question. So our answer to 12 is F. Alright, maybe like a turquoise? Are we feeling a turquoise for the next color? How about a light green, because that's the pen that works. Alright, 13. If a new trial were conducted, these are some of my favorite questions, and on the interim we tend to get this one wrong a lot, is predicting what would happen in a new trial. So if a new trial were conducted with the conditions of trial 9, except with double the current. So what if we increase the current? So we did the current times 2. What would be the recorded height of the metal ring? So now we're going to go find trial 9. That trial 9 is our locator. So I'm going to flip back and I'm going to look for trial 9. So in trial 9 we had 100 coils and we went up 1.5. But what if we doubled the current? Now this says that the students used the same amount of current in each trial. The same. So we have 100 coils and it went to 1.5. But what if we put 2 times the power and kept 100 coils? What do we think this would go to? My guess is it would multiply by, so it's either going to and my guess is it would multiply by 2, probably, right? So it's at 1.5. it's at 1.5. And times 2 would give us 3. So I'm going to go with 2.9 because that's going to be the closest one. Questions on that one, please ask me in class. And last one. Suppose that students repeated the conditions of trials 1 through 4 of experiment 1. So, table 1 is my locator because that's what experiment 1 looks like. Except that they used a coil with a diameter of 4 centimeters instead of 2. So, they went from 2 to 4. Again, that's increasing something by 2. Based on this passage, how would the results of this new experiment affect experiment 1? So, we're looking at trials 1 through 4 on this one. Okay, it's at this time, what we're changing is this. So this diameter has doubled. So that's times 2. So what would happen to these answers? My guess is it would also times 2 increase, right? So we're increasing it. Multiplication in general is an increase, and the division is your decrease here. So I think that they would both increase because you increased the whole setup by 2. So let's find something that says increase, increase. So that's both decrease, no, because we multiplied it by 2. Increase and then decrease, that just doesn't make sense. Increase, increase, both increase. Great, my answer for 14 is H. And that's that.